Good morning, good evening, depending where you are on this planet. Welcome to Swift Community Meetup number 8. As usual, my partner in crime tonight. I don't know what to say today.
This night.
It's Janice. Janice, you're in the Netherlands. I'm from Belgium. I'm based north of France, and we are broadcasting worldwide on YouTube. And this video stays available for a long period of time, forever, on YouTube after the meetup. We have a quite exciting agenda tonight. We're going to talk about AI on the edge device with the NVIDIA Jetson and Mihai that will show us what is possible to do in Swift today with AI on the edge. And Leonhard will talk about the migration from Spring Boot to Swift in the context of data pipeline. But before they start, Janice, any things that you remember that you want to highlight from the last few weeks, the last few months in the Swift community?
Yeah, so I've been quite impressed by the progress that WebAssembly has continued to make. Especially like there's now a new document or a new proposal to improve this support with mscripten. There are a lot of new WASM use cases popping up all over the place. Swift on Android is nearing a first proper release, non-beta release with Swift 6.3. Valky reached 1.0, the new Valky driver. 1.0. It's an amazing driver for a database driver for Swift. And on top of that, the Swift ecosystem steering group has published a document outlining the vision for networking in Swift on all platforms. So some really exciting new things popping up all over the ecosystem.
Yeah, that document is super interesting. I gave it a rate yesterday. I'll try to find you the link and post the link in the comments to read after the meetup. Don't read that during the presentation.
Yeah,
but
in general, the forums are really good to keep an eye on because there is just so much exciting stuff happening all over the ecosystem all of the time. So it's good to stay in touch just through observing the forums passively.
And end of January, there was also FOSDEM, which is the largest open source conference in Europe. It's in Brussels, in Belgium. And Apple organized for the community a pre-FOSDEM community event. We had talks all over the afternoon and a very nice drink and dinner at night. All the talks have been recorded. So if you go to the YouTube page for this meetup, by the way, we renamed the meetup Swift Community Meetups. You will find not only the former meetups, but in the video tab there, you will find all the talks from that day. And it goes from edge device with a presentation that you made, Janice, to building a website and cryptography and tons of interesting topics. So I let you discover the talk over there. Just like usual, tell us where you are if you are watching this meetup live. There are some familiar name. Yeah, looks like the smiley, the emojis are not correctly converted here. Hello, Madi. I hope you're well. We have Servus from Munich. I see some familiar names. Eric in Belgium. Steven. Hello, everybody. So leave us a small message saying in which city you are or in which part of the world you are. We love to read that. And don't hesitate to drop your question for the speakers as well. We are not going to interrupt the speakers during their speech or their demo, but drop your questions there and we can open the microphone and discuss with them just after the presentation.
And if you have any questions for the Swift server work group or any of the other open source folks around, feel free to drop those too at any time. I will cover them at the end of the meetup.
And our first guest tonight is Mihai. Mihai, good evening, good morning for you. You're in the US. Welcome, and I'll let you share your screen, and the stage is yours.
Sounds good. Thank you guys for having me as a guest. It's good to be here.
We have more message coming from Italy, from Ottawa, in Canada, from Hanover in Germany. Great to see that you're joining from all parts of the world. I receive your screen. Yes, I receive your screen. So I'll let you start Swift on the Edge.
Okay, nice to meet everyone. I'm Mihai. I live in Berkeley, California. Been a software engineer for, I don't know, more years than I can count. I'm a generalist. I've been all over the stack. In the past year, I've been working quite a bit with some interesting devices from NVIDIA. It's the Jetson range. And today, specifically, I'm using a Jetson Orin Nano or Jetson Orin Nano Super. I would show it to you. It's tiny. It's slightly larger than a Raspberry Pi, but unfortunately for the demo, it's hooked over USB to my laptop and I can't pull it out. But feel free to Google it. It's actually a really cool device, and it has a lot of capability, especially in this new world of AI for such a small package. In the past year, I've been playing around with it and also have been a student of Swift. My background is not Swift. I've only been doing this for a year and been playing with computer vision a bit. Also nascent for me. It's a new skill that I'm acquiring, but it has been quite fun. I want to show you what I've come up with. And it actually uses Swift and it runs on an NVIDIA GPU. This is, after all, a tiny GPU. So I'm going to, let's see if I can actually switch to the demo. This is a little dashboard. Nothing seems too crazy here, but I'm going to walk you through what you're actually seeing. So this is a TP-Link Tapo camera. It's like a $15, $20 camera that is in front of my house. So you're seeing a live stream from Berkeley, California, in front of my house. And I'm using a model to detect, I just specifically zero down on cars, people, I think animals, motorcycles. There's a specific reason for the motorcycle, but I'll get to that. It's looking outside my window, and on my desk I have this Jetson Orin Nano. It's hooked over USB to my laptop, and it gets a stream from this camera, and it processes it, it detects things, and then it shares this video, as you see with those green boxes. And you can see as cars are passing by that it detects stuff and whatnot. And in this little dashboard, it might be tiny, but if you see the URL, it's actually an HTML file that's on my laptop. And you can see at the top here, the device is basically a local host IP because it talks to the Jetson over USB. And you can see the detector is running at about 20 frames per second. It's keeping track of two things at the time right now, sometimes three. And I'll get into that. The latency is 50 milliseconds. I have some improvements that I can make to make it faster, but I'll talk about them later because I didn't get a chance to get them ready for the demo. And then classes of things that it detected, you can see them here. And then I'm going to show you another thing here. This is a Grafana dashboard. So I have some Prometheus metrics coming from the device to actually see what's going on. Some interesting facts here. Obviously, you can see the frames per second process. There's clearly a memory leak over here. So I did something wrong because the memory is going up visibly. The CPU utilization is a bit off, but I'll share some more about that. And as things are detected, you'll see this GPU utilization go up. I'm going to go back to my slides and actually walk you through what's going on here. I did something funky here. I used the tool to make this diagram, and it doesn't seem like it renders really well in the slides. But let's go through some of the details. So we get the stream. This is an RTSP stream that's coming from the camera. It's H.264, 1080p. We have FFmpeg running in a subprocess from Swift, and it it essentially takes frames and then sends them to our detector app. There's something called a VPI, which I believe this is from NVIDIA. I believe it stands for Video Processing Interface. And there's a hardware component to it so that it can actually resize images. The YOLO 11N model that I'm using, it's not super fancy, but it needs 640 by 640 to actually do detection. So we need to resize. There's a fallback here for CPU in case the VPI doesn't work for some reason. And then we have the detector engine. This is an interesting bit. We run the model using TensorRT. This is an inference engine from NVIDIA because it's optimized to run on these specific GPUs. It's very hardware focused, and it has some C headers that it exposes. Then we have the YOLO post-processor, which decodes the result that we got from there. And then we have a tracker, IOU. It stands for intersection on union. It's nothing fancy here. It's an algorithm that essentially avoids detecting the same car as it moves through the screen so that it can actually track the same thing and not say that it found, I don't know, hundreds of detections of the same thing. And then we have a frame renderer because we want to see the video with the boxes on it. And we're exposing that through Hummingbird, an HTTP server you're probably familiar with. And then that's how you see it in the monitor HTML that I just showed earlier. So that's at a high level what's going on. We do have some Prometheus metrics. Obviously, I've showed you the Grafana dashboard, so it's harvesting some data from there. And I ran a hacky thing in there to actually get GPU metrics. There's a process called Tegra Stats on these that exposes GPU temperature, power usage, things like that. And this is a little tricky to run in a container. I forgot to mention, all of this runs in containers using containerd. I'll get into that in a bit. So this is maybe a good opportunity to get a little deeper into what's going on in here and what we use Swift for. The interesting bits here is that I picked Swift for this in an interesting way. So I started the project initially with Python, and there's plenty of Python libraries, but it was actually a pain in the ass to work with because of the dynamic nature of it. So because this runs in containers, we need to somehow hook into the libraries that are on the device. And sometimes getting that right with Python packages, it's actually painful. So you have to do it at runtime, and then paths are wrong in the containers, and you're linking the wrong libraries or from the wrong paths, or the Python package is looking for a different version of the library on the device. It's actually, if you look it up online, the dependency hell is quite real for NVIDIA devices. So I figured, why not use Swift for this? Because it has C, C++ interop, no FFI. It lends itself pretty well to using these libraries. So there were some challenges with this, but the one interesting bit here is, for example, TensorRT. I didn't do this myself. There's a library called TensorRT Swift. It's an early version, but it worked like a charm, and it just hooked into the libraries that were already on the device that I just linked inside the container. So that was very, very useful to access the GPU and do GPU processing. I'll actually skip to this slide because it talks a lot about the Swift ecosystem and what I'm using here. I mentioned TensorRT Swift. Hummingbird, obviously, it's a popular name from what I could gather in the Swift community in the past year. Hi, Yanis. Swift Prometheus, because I need that for metrics. So I leaned a lot on the ecosystem. I didn't reinvent the wheel myself. Argument parser and whatnot. The one thing I didn't mention is how I deployed this into the device. So there's a tool called Wendy, because you saw I'm the co-founder of this, but I didn't want to advertise too much, but I've been using it. It's an OS that we customize for the Jetson and not just the Jetson, and it has everything you need to actually do the stuff. So the C libraries, the NVIDIA drivers, everything is packed in the device, and then there's an easy way to run containers with containerd, and you have a CLI on a Mac or a Linux to just essentially you do a Wendy run, and then it builds your package. It does cross-compile, and it sends it to the device, runs it there, and the libraries are already linked into the container. So it works like a charm. So those are the deployment rails. It's pretty straightforward. You don't have to do a lot of plumbing, which is great. And then I did mention cross-compilation. So this was an interesting topic because in order to do the linking on the device, because I was doing cross-compilation on my Mac, I needed to set up to create a custom SDK that has all of these libraries, so I can build and actually ship a binary, the container, and have it link to the proper devices. So I used the SDK generator, and then of course pass the SDK that I generated to the to Swift to use it during the build. Right. Okay, so at a high level, this is what's happening. There are several reasons for actually trying Swift here. Considered Rust, it doesn't work as well with NVIDIA C libraries, of course. It's a lot more complicated. I mentioned the Python issues. I mentioned the linking and what happens behind the scenes with Python. That is actually a pain in the ass. And there's also the management of all this. So one interesting note is in several spots I used Swift actors because, for example, the access to the the video processing interface here. So the libraries from NVIDIA are C, they're not thread safe. So that's actually pretty dangerous if you have multiple threads accessing this hardware, because you can have mixed images in there. You can have failures, crashes, and whatnot. So you don't have to, in Swift, you don't have to think about that that much. So these were wrapped with a shim, and they're wrapped in Swift modules, and I'm using an actor there. So that helps a lot in keeping everything safe. So it's another benefit to Swift, because I've done my C and C++ in the past. It was fun while it lasted, but it was a challenge to keep up with the memory, especially in these contexts. Okay, so I went through a lot here, and I'd be interested to open up the floor to some questions, because I'm happy to try to dive deeper into anything related to this.
Oops, time is for questions, folks, in the comments. Do not hesitate to ask questions. I have one to bootstrap the flow of questions that I hope we will receive. What other use case do you see besides computer vision for this type of AI on the edge or AI on the device?
Very good question. So I used a basic and known model. It's called YOLO. It's for object detection. It's very popular out there. Initially, when I built a similar project in Python, I also was able to run a visual language model, which becomes quite interesting. I ran QN 3.5. The latency is not in the milliseconds, it's in the 30 seconds, but technically you can have a prompt, a custom prompt, and you can ask it things about a video. And I was able to run this on this device. So it gets interesting. This is vision. However, anything machine learning that you want to run on such a device on the edge, even battery powered. I actually had this device run on a battery for a while because nitty gritty, it has a barrel power jack and I had a bunch of USB-C all over the place. So I just wanted to carry it around and show to people what I'm doing. Sometimes coffee shops don't have a power outlet and whatnot. So I actually had it running on a battery. The device is actually used in drones quite a bit. So it's very vision adjacent because the applications for this are for things that are on the move a lot, not very static, because you can get much more GPU power and processing power if you have a static use case. There's some other interesting, I'm going to get nerdy with this, but there's some other interesting features that the device has that I want to test. I mentioned the VPI. That's something that is separate and takes the load off of the CPU and off of the GPU for video processing. There's also image encoding and decoding. There's a chip, there's a hardware that does this. I've had some trouble wrapping that. It needed some kernel module changes and whatnot. It was getting deep, so I didn't get it ready for this demo, but that's an extra step that I want to do to see if it works. This goes into, I showed you about the CPU usage there. It was high because some of the image decoding from a frame to RGB happens on the CPU right now. That doesn't have to happen on the CPU. There's an extra chip there that can handle this stuff. It's just dealing with all the packages and dependencies to actually use NVIDIA's software stack to use that is a bit of a challenge sometimes. So yeah, it has some interesting features that are particular for video. And there's video use cases are quite a bit out there, especially if you get into the VLM space. It gets more interesting, it gets custom and whatnot.
Talking about drones, X2B4 is asking if you try various sensors via the GPIO port.
I've not tried them myself. I think the video part was a little bit of a more interesting challenge for me. It does have GPIO. I think it maps perfectly to the Raspberry Pi GPIO mapping. So you should be able to use them the same way. I've not tried it myself.
Mm-hmm. And a question from Eric, since you mentioned running FFmpeg as a subprocess, are you using the new Swift subprocess library to launch FFmpeg?
Yes, I forgot to mention that.
Cool. I saw on the Wendy OS page that, and you mentioned it, that it also supports smaller devices like the Raspberry Pi or some type of Raspberry Pi. What type of performance can we expect if we run models on these smaller machines? Do we really need an NVIDIA Jetson? That's my question.
Well, YOLO runs almost everywhere on commodity hardware. So an interesting aspect here, I ran it with TensorRT, but it can run with different inference engines. The model itself, it became actually quite small. I had to convert it to a particular format to run it with TensorRT. But the result was like an 8 megabyte model file. So YOLO has been out there. I think some people run it even on an ESP32. So the model itself is not that interesting. Technically, you could swap the model with a different model and do something more sophisticated there, so you can get more heavyweight. I also use the YOLO 11N, which stands for nano. I just thought about this before the presentation that maybe I should try one of their bigger models and see what I get with that, because there are some bigger ones too. But I'm with you on this. You're not going to have things like TensorRT to run on the GPU, on the Raspberry Pi and other devices, but you can run YOLO on the CPU. So the detection part here is not novel in and of itself. It's just the use of the GPU.
Yeah, and on top of that, you could run MLX already on the CPU, which has a flourishing ecosystem on macOS and iOS at least, which is, hopefully soon on Linux.
MLX, it's the open source framework from Apple, correct?
Yes,
that was
correct.
designed for Apple Silicon. So you're saying that you can run MLX now on other type of architecture or operating system?
Yeah, MLX supports CUDA on Linux as well. The only downside is that the CUDA version for Linux currently requires CMake, not SwiftPM. I've personally been working on helping them out a bit with that. But yeah, you can already run MLX on Linux with CUDA. The kind of caveat to what you said is it was kind of designed for Apple Silicon, but it was more so designed for unified memory architectures, where the CPU and the GPU share memory, so they don't need to copy their data back and forth between A and B, like between CPU and GPU memory. And the Jetson also has unified memory. Yeah.
The other segue, something I didn't mention is that usually NVIDIA graphics cards have their separate video memory, GPU memory. The Jetson range actually has unified memory, which makes it even more interesting. So another optimization that I could exploit here is all those chips that I mentioned for video processing, using NVIDIA's libraries, essentially wrapping them with Swift. And using them would mean that we could get into a place of zero copy from one to the other. So that makes it even more efficient.
We don't receive any more questions on the stream. Anything to conclude? Where can I get started if I want to get started? I need to buy a Jetson Orin card or a Raspberry, and then.
Yeah, for sure. If you want to use the GPU, obviously you need the Jetson. Yeah. Raspberry Pi would do as well. And I haven't shared this project yet in a GitHub repo, but I'm happy to open it up for people to take a stab at it and play around with it.
Is there any source that you can suggest to get started with computer vision for someone that has already the foundational knowledge of machine learning?
A source that I can suggest for computer vision. I think there's a website called OpenCV, and it has a bunch of resources and talks. That one's interesting. And I read a lot of the docs from Ultralytics, which is they make the YOLO model. They have a lot of good docs, even things related to Jetson, Raspberry Pi, and other devices. And there was something else that I read that I can't remember off the top of my head. But essentially, I just went from link to link.
You can post it in the comment while Leonhard will deliver his talk. One last question that just arrived. Can you process multiple video streams with one Jetson device?
Very good question. Yes, you can. The other interesting fact about the video decoding, this one particularly doesn't have the encoding part, so on the output, but for the video encoding, I think it can take somewhere around 4 frames at a time, so you can have easily have 4 streams that send frames and decode them at the same time. But I've heard of situations where you went up, because this is reading from the network. You don't have necessarily a limitation on ports on the hardware. So you can bump it up to probably 8 to 10 streams and have reasonable performance.
Thank you, Mihai, for the explanation. I want to get started with physical device. Every time I hear Janice or you talking, I want to get started. Thank you very much.
Yes.
Just a bit around on the stream. If other people want to ask questions during the next talk as well, you can answer them online. And talking about our next speaker, Leonhard, good evening.
How are you doing?
Hi.
Hello. Good evening. So we are going to switch subject totally, going back to the traditional server side, a good old Linux machine, probably running somewhere in the cloud or something like that, talking about data pipeline, the AI data pipeline, and the migration from Spring or Spring Boot to Swift. The stage is yours.
Thank you. So yeah, we've done some quite interesting migration work from something very traditional, Spring Boot, to Swift. As you can probably tell, I'm coming from Germany. So in our culture, of course, security is something very important, and tech companies tend to not do very, let's say, tend to stick with very well-known or traditional frameworks. But we still decided to migrate to Swift because also I found it a very, very interesting language. And I want to share a little bit of my reasoning process, of the transition process, and how everything went and why we did this decision actually, and what it perhaps tells us about the Swift ecosystem and the state of the Swift ecosystem. So basically, who are we? What are we doing? I'm Leonhard. I'm founder of my own company, Solbach Leads. And basically what we're doing is we're doing B2B data research. And for that, we are on scale processing millions of companies in the German-speaking region of Europe. And the use case is basically building total addressable market, matching companies to ICPs. Not very interesting perhaps in this context, but basically what we're doing is we're running a ton of queries on large language models, and we do a lot of vector searching, a lot of writing to databases, reading from databases, using complex queries. And what we used to do is we used to work with Spring Boot and Kotlin, which is of course a very traditional stack. Everybody knows it, and it's reasonable. And you would expect, we start with the thesis, that it has a very mature ecosystem and everything just works fine. And this is, of course, what's also being sold. And sometimes this is also what happened to me, was when I researched Swift, the Swift server-side ecosystem, there were some old posts online basically claiming that Swift was not mature enough, unstable, the ecosystem wasn't there yet, everything. I would like to question these points today a little bit from our own research, from our own experience. And basically, to start, what do? We build, of course, with Spring Boot and Kotlin, very traditional stack. So basically, to put the meme first, what we did was something like this. We had a 2 GB Docker image. It took basically forever to start. And Peter Steinberger is, of course, a well-known person by now. But just when I saw this, I found this perfectly described our situation. And why did it come to this situation? What was our workload? Of course, we have like 4 million companies. We have 10 terabytes of data that we're processing, at least 2 terabytes of them actively, actually. Those are HTML files, screenshots from websites, filings, register extracts, basically a lot of PDF files. We have 4 million companies. We have 13 pipeline steps right now per company. And it's very, very, of course, I/O heavy. We're using Postgres, S3, vector search, everything. And what we have decided from the first start was, of course, starting with horizontal worker scaling, using a Postgres-based task queue. And as you can probably imagine, this came, of course, with our own problems, especially in the Java ecosystem. So why do we migrate? Of course, I have known Swift since a very long time. I always found the language very interesting when it comes to language features, syntax. But there were basically 4 main, let's say, pain points. First of all, of course, worker economics. What we're doing with Java was just bad for horizontal scaling. I will get into that later. The concurrency models, people always tell you it's very easy in the ecosystem to get around. But what we found out was that actually having it like Swift have one concurrency model, type concurrency, async await, was very much to prefer against what we have in the Java ecosystem, what we had previously. We had coroutines, flow, reactor. Some parts of the code were not reactive at all, and we always had to bridge that. That introduced a lot of friction. And also, we're a relatively small company. We have 4 people right now, 3 of them actively working as developers. And especially for what we're doing, the framework was more holding us back than actually providing us any value. And also, especially in the AI parts, the APIs usually moved so much faster than the JVM wrappers. And the JVM wrappers usually forced a very, very tight abstraction. So if something changed, it just didn't work. There was no way around it. And basically what we found was those very, very tight abstractions didn't allow us to do what we wanted to do. So basically, what we had, if you wanted to switch a model, for instance, you would have to wait 2 weeks, or 2 weeks, 1 week, until somebody updated the enum in basically all the libraries that there were outside, Spring AI and also JetBrains Cog. And that was just not really feasible for us, because why would you have an enum for this, for instance, in the first place? Why would you not just let us use the model we wanted to use? So while there were a lot of official frameworks, at least for us, it was not very pleasant to use all these existing frameworks, let's say. And also, of course, what we had in the beginning, I already told you, we have workers, a worker-based approach. So we are easily starting 20, 30, 50 instances of a worker of workers. And when you have memory at idle of around 400 megabytes, right, it's just not so good, because it eats up memory like crazy. And also the cold start, I'm saying Swift was less than 1 second. In our experience, it's more like 50 milliseconds. So it was around the factor of 1,000 faster. And you could really, really tell that if you wanted to redeploy something, you can just see for this, at least for this around 1 minute, that there was no progress at all anymore. And at least for our use case, this was not very feasible. And of course, I know in the Java ecosystem, you have all sorts of ways to work around it. So you can use some ahead of time compilation. It's very, very difficult to set up and to maintain. So we never did it. And it remained a huge pain point for us, of course. So how do we approach our migration? First, we built the primitives. Then we started to implement some step for us, some first pipeline step. We then continued to compose the full pipeline, and and at the end we of course had to test it somehow. Some concrete examples of what I mean, of what actually went much better for us. When I talked about how the frameworks, in at least my opinion, hold us back and were not very useful in our use case, this is also what I mean. In Swift, we were able to use postgres-nio to write SQL queries directly in the code without having to rely on any annotations, any repository interfaces, mapping of entities. And what we found from the existing ORM systems, and this is a critique of ORMs in general, is that they provided little value. Because when you build a quad application, it might be helpful, but nobody who's adding any kind of business value, of course, is just building a quad application. And this is why postgres-nio came in very handily, because of course there is no explicit SQL generation for you based on some entities. And of course, I know this also exists in the Swift ecosystem as well with Fluent, but especially in our use case, postgres-nio was brilliant because it's super fast, it's super reliable. You can just explicitly write the code that you want to be executed without having to rely on any converters, etc. We also had the problem in our use case that for Spring Boot to work with vectors, we had to register some specific converters. And all those magic in the existing Java frameworks actually turned out holding us more back. This is something I'm perhaps repeating here, than it actually helped us. And circling back to the beginning point, I was expecting that the existing ecosystem around Java that we have been using basically as developers, we all have a Java background, our whole lives, that these abstractions would be so much more useful. But in reality, when I revisited that point and looking back at it, none of this was actually helpful. And some more concrete examples, our pipeline orchestration. Back in the Spring Boot times, we of course had, as I already said in the beginning, we also had all sorts of different concurrency models. We had reactive, then we had coroutines, we had non-reactive, we had Java virtual threads. We always had to bridge around it. And this also just added so much more boilerplate code, of course, and so much more friction for the development, especially for a small team, than just doing it the way Swift does it, using structured concurrency. And this is also something that I want to emphasize. In our Swift ecosystem, we could just easily find a library where we could feed screenshots into a language model. We had to fork something for that in the Kotlin ecosystem. So I want to continue questioning the notion that Swift is not production ready, or that there are just not many usable libraries in Swift. This is not what happened in our experience. I want to stress this repeatedly here. So basically what I said here, in Java, we had to rely on a lot of wrappers that lag behind the actual APIs. Swift, we were using any language model for this. You can check it out. It's amazing. Check it out on GitHub. Was very much more tied to what the providers, the LLM providers actually offered us, was so much more closer. And this, of course, offered us so much more rapid adoption of new features, like, for instance, the responses API of OpenAI. And looking at the current production stack, this is all the libraries that we're using. All of them are production ready, of course, and none of them are tied together, so we have our own choices compared to what we had previously in Spring Boot. We could easily swap out some library. It's not opinionated. We can write the code in the way we want to write our code. This is also a great benefit. And as I said, it just worked perfectly fine for us. Some trade-offs are what we basically noticed. We usually, as Java developers, of course, we are using IntelliJ. VS Code worked surprisingly well for us. I wasn't using VS Code before. Actually, much better than Xcode. Of course, it would be nice to have some better tooling in the IDE we already knew, IntelliJ. However, they killed app code, so you have to rely on some third-party plugin for that. I find it very sad because, in my opinion, IntelliJ still is a great IDE, but it's just the way it is. JetBrains decided to kill app code, even though I think it should be very easy to just revive it in some way. But yeah, I think what we gained significantly outweighed what the trade-offs were. We have instant worker startup, and we can really notice that even if those workers are running all the time, when we want to deploy something, it's there instantly after the code is being built by the CI pipeline. We have one concurrency model. We have perfect I/O control, no ORM magic, and just what I personally felt, and this is what I said in the what our resume of the migration is that the Swift ecosystem, at least for smaller companies like ours, works so much better and is so mature actually already that there is just no question whether you should migrate or not if it does fit your purpose. Or let's say in hindsight, for us, it was a no-brainer, let's say. So yeah, basically coming to the key takeaway that I already told you, Swift works perfectly for our I/O heavy workloads, for our worker-based approach. It's not only about syntax, of course. Even though I love the Swift syntax, it just allows us to move with so much more velocity. And that's basically it for my presentation. I'm very open to questions. And yes, that's it for my part regarding the presentation.
That's super interesting.
Thank you for the presentation, Leonhard. Yeah.
Do you have some data about the gain in production? You say that your workers are starting much faster, that you can put more worker per node and have a higher density of your node. But does that translate to cost efficiency, performance, latency? What are your observations there?
Basically, we're hosting all of our applications on our own hardware. So we don't particularly have less AWS builds because we're not using AWS, for instance, or we don't have any less cloud builds. But what we have is a much higher throughput. So instead of just running 10 nodes on the previous hardware, those are made up numbers. I think it was around 10, perhaps it was 10 to 15, something like that. I would need to look it up. We can run around 3 times the nodes. So we have 3 times the throughput than previously. But what I think was the most interesting observation in our migration was just how much more developer velocity we have. Of course, we come from a very, let's say, boilerplate enterprise-heavy ecosystem, but still, it's very interesting for us to notice that.
There is a question from Stephen about the new temporal SDK for durable functions that was introduced. I guess it was at the server-side Swift conference in London in December last year. Is it something that you consider?
Yes, we considered this the SDK. It's for our use case right now not the ideal fit, but we actually plan to introduce it later down the line once the migration of the existing software is done, once we're implementing new features. And yeah, if we reviewed the SDK, it's brilliant to have something like that. It's very easy to use from what I've seen. But what we're doing, we are executing a lot of tasks concurrently, and there is not so much state between those tasks right now. So what we're doing is, for instance, we process 200 companies. What we're doing is we're finding out, for instance, what is their revenue based on their balance sheet, what investment decisions have they done in the past few years, because in Germany they are at a given company size required to report that. And basically it's a lot of extraction work. So it's temporal SDK will be used in the future, I think, especially once we move to more agentic workflows. But right now, the task queue-based approach, the reporting over from our previous implementation works just fine.
One of the advantage we heard when migrating to Swift as well is the strong type safety and the concurrency check that the compiler is doing to try to catch more bugs at compile time instead of runtime. So of course you had the type safety with Java and Kotlin as well, but from the concurrency, did you notice a reduction in runtime errors since you migrate to Swift? Is it something you can measure?
What I did notice was more meaningful errors, because especially in our setup, we had the problem that our Java stack traces become pretty much unreadable because we have a lot of tasks, and the way Project Reactor works with coroutines, yeah, it just was very nasty to debug. That's actually something that Swift significantly improved on. Regarding the errors that we're facing, they're mostly, let's say 99% are exceptions based on the LLM providers. Some task timeout. So not particularly in this case, but for the development, of course, it's very, let's say, very beneficial, very nice, not to having to worry about data races at all anymore. I would say we gained that more on the developer velocity part. Also, of course, async await is a huge benefit over what we had previously. We don't have to bridge between 3 different concurrency models. And what we, perhaps when I recapitulate, what we did have is very untraceable errors when the bridging between those 3 concurrency systems failed somehow. Those spurious failures that we had previously are basically gone. That's perhaps something, but that answers your question better.
Yep. Jenny, is anything on your side? And for the audience, any question, drop them in the comments.
What I'm curious about is, you mentioned that the error rates are mostly from LLM providers. How did you tackle traceability and the whole observability story in your setup?
Right now, we have error logging based on each task. So once a task fails, we are getting feedback, basically, which part of it failed and why, with a basic message attached to it. Observability tracing is something we want to implement in the future. I know Swift has great solutions for that, but right now, we didn't have enough time yet to mature our infrastructure. We are migrating over from a Docker Compose-based stack to Kubernetes right now because we have so many different machines and we need to orchestrate them. So observability and will be something we will approach at a later stage.
Makes sense.
How do you deploy? Do you deploy to container? You said it's machine that you own, but is it on container or within containers, or do you deploy directly on Linux?
We're Dockerizing everything. Our deployment is actually perhaps a little bit off topic, but also interesting. Since we need a lot of performance per watt, let's say, we're also deploying on a Mac Studio right now using a Linux VM. So that's also something very interesting for us. And basically what we have a very heterogeneous set of machines, some ARM machines, and some normal servers. Some of them are at a data center, some not, and all in different locations. So yeah, Kubernetes is very much needed for orchestrating that right now. And we are looking forward to add a lot of new Mac Studios to it because the performance is just incredible.
Mm-hmm. Eric mentioned that you explained that you rewrote your application stack from Kotlin to Swift, but have you explored the Swift Java interoperability to progressively migrate some part of the code base?
No, sadly not. What we decided to do was not only to migrate the existing stack, actually we also improved the business logic. So the existing source code was of little value to us anymore. And also, once you have some Java code running, you obviously get the problem with the memory again. It's just the JVM is like that. It's very memory consuming. So we just killed it all together, basically. And
how long did it take to rewrite your software stack? Was it a project in weeks, in months?
I have done a diary. So basically, we started on 8th of December.
Oh,
so,
okay.
Oh, it's very recent.
It's relatively recent.
Including the holiday period.
So yeah, it's recent, let's say, but we've made great progress so far, and perhaps some insights on the production. What we noticed with Swift, of course, is also I've mentioned it in the talk a little bit. It's just incredible how fast you can redeploy it. It's in the startup time. It's literally not even executed. It's 1000x because it's 50 milliseconds versus 50 seconds. Especially if you're deploying on a server that is already under load. The whole bean registration, reflection, it takes forever. And I know there are options in Java, and they're always, once you're talking to other Java developers, this is what they refer you to. But it's ultra complex to set it up. It's really hard. And in many use cases, it just doesn't work at all because there's some Java dependency you're using that is not supporting ahead of time compilation, and then you're out.
Mm-hmm.
And that's perhaps the most interesting learning is how much we were able to increase our developer velocity.
So from the time to write a change to the time that change is in production?
Yes.
So your next project will be in Swift as well?
I think so, yes.
On the back end, I mean, on the server.
Yeah.
Yes, of course. It will be. And also perhaps something before we end. Coming from Kotlin and having some experience with other languages, it was very easy to learn Swift for our developers. We have 3 people who are developing actively right now, including myself, and none of them had significant problems.
Did you have any resources that you really liked? while learning Swift that you would recommend others?
Not really, but I'm in the process of recording a course for that. And I will make it public once it's finished.
Cool.
That's interesting. It's something I missed in your talk. You said you're coming from a Kotlin Java background, so you didn't choose Swift because you were already familiar with Swift coming from the front end or something. You chose Swift for the intrinsic advantage or benefits that are advertised from the language. Did I understand correctly?
Yes, that's right. None of us actually has any experience in writing iOS or any Apple side applications. Now that's not entirely true. One of our developers has now, but basically we didn't choose Swift because we
You knew it. Mm-hmm.
But quite frankly, I've been monitoring the situation, monitoring the progress since a few years, and was very interested in the language since I first saw it.
Have you considered alternatives like Rust, of course, or it might have been Python or anything else?
I've considered TypeScript and Rust and Go. Why did I choose Swift? It's relatively simple, actually. If you look at Rust, for instance, it's a great language, especially for low level, but the learning curve, in my opinion, is quite steep. And also, from my personal perspective, the language gets a little bit too much hype because everybody's claiming once you write it in Rust, it will be perfectly safe and you can't do any mistakes anymore. And it's just not true.
It's not true.
And it was a little bit too difficult to move over to Rust from what we knew previously. So Swift was the easier choice. Also, TypeScript was an interesting choice, but I still chose Swift over it because, first of all, it's more familiar. You have better concurrency models, which we need. It's still much more performant, of course. And ecosystem-wise, it didn't make a difference for us. Our frontend is built in TypeScript. We knew TypeScript very, very well, but Swift was still the better choice. And regarding Go, it's the same. It's the same reasoning behind it. The language is good. It's a great language, of course, but in our use case, we already knew Kotlin. We love, I personally, or our team likes to have a object-oriented language with some functional features like it was in Kotlin. Kotlin has, in my opinion, also a good syntax, which is just totally missing in Go. Doesn't mean that doesn't mean those people developing those languages aren't good in their own sake, but for us it was just the more obvious choice, let's say.
You mentioned developer velocity. Of course, Go has really good compile times.
Mm-hmm.
Was there a really strong reason for considering Go over Swift there, as anyways, or how did you feel about that?
It's true. Swift does have a little bit worse compilation times. Also, the LSP plugin is sometimes a little bit buggy, let's say. But in my opinion, we're still able to, from going to something has been pushed to main, to we have an image on production in less than 1 minute right now. So compile times have not been a great issue for us. But what has been an issue is the language and the syntax itself, because Swift has a very powerful syntax, very powerful type system, very powerful object-oriented and functional principles, which in my opinion are not yet there in Go, and I think will never be there in this way in Go. From what I've known, Go didn't have generics for a very long time because they wanted to keep the language very simple. And perhaps that's something good in their use case, but and our team likes having a language that is more versatile, let's say.
Yeah.
There is no more question on the stream. Janice, something to add?
None for me.
Looks like we are going to call it a day and finish here. If you want to present at an upcoming Swift community meetup, let us know, Janice or myself. We are available on the Swift open source Slack, on LinkedIn. You can find us very, very easily as well. We are always looking for speakers, IDs, anything you did with Swift on the server, Swift on embedded device, Swift on web browser,
Android, WebAssembly.
Android, exactly. Anything except the traditional iOS and macOS application. Thank you very much. This video is staying online. If you watch us online in the future, hello from the past.
Join us in the next meetup as well.
And next meetup will be in Q2 somewhere. We don't have a date to announce yet, but it will be done on the Swift forums and the Slack and social networks. Leonhard, Mihai, thank you very much for your time and your presentation today. Janice, thank you. And see you next time.
Bye.